All right, so how is it going?
Okay.
Going good? How is the course? I have to admit, I checked and I see much activity. You guys are on the platform, so that's good. I can see that information and I'm very impressed. Also, I looked at your introductions and also impressed with the mix of students and that there are, oh, I didn't count. I didn't take enough time to count, but it looks like there's maybe a third of you have statistics background, so that's good, or at least working with statistics in their job. That's very interesting. So that keeps me on my toes. Feel free to challenge me in the things that I say. Don't hesitate. Um, if you have questions. So let's talk about what we're working on today. We're going to review Módulo 3. If you have anything to ask about Módulo 2, we can talk about that too. Let me look at the platform with you and review where we're. So from the top, I put some things in here. I think I'm going to delete, I'm going to clean it up because otherwise you have to scroll a lot, right? But I just put that there to remind you that was Modulo 2. If you want to see it again, you just have to click here because I'm going to suppress it. So you won't see it on the front page. This too, someone asked me to produce the experiment, and I hope that helps for this exercise that we did in class. All right, so here's the timeline for our schedule. And we are currently in here looking at graphing and descriptive statistics. So in the first, or in the last module, we talked about gathering data, and now we're moving into how to work with the data once you have it. Okay, so we're doing one step at a time. You have still one more week to finish, but today I want to see how far you got with this module. It's quite big, and there's a lot of exercises and videos to see. The textbook exercises, if you've purchased the Connect, the exercises there are in study mode. I'm going to convert them into, I'll do that today after the class. I'm going to put Connect assignments up so you can start those as well. Once an assignment is visible, you have 2 weeks to complete it. So you can spread out, there's no rush. There's no rush to complete it once it's up. You'll have some time. And so we're working towards, right? So we have still have a month for the first test, and we are on schedule. We'll see today how you are, how you're advancing. Okay, so were there any problems with the purchasing the Connect? You'll need to let me know.
Yes, I tried to purchase it, but it didn't let me add to the cart. It said that I had to write them an email to see if it was available.
Okay, so maybe they don't have enough available. Who else had trouble like that?
Yo, Alondra Crespo, me pasa exactamente lo mismo.
Did anybody buy it? How many people got the text? Okay, so maybe they allocated just a few. They didn't realize they needed more licenses. So put it in the chat if you have. So anyway, don't worry, because I will put it shortly. If not by Wednesday, it'll be by next week. No rush. You will not be responsible. Like I said, if I put an assignment up, you'll have 2 weeks anyway. But yeah, put it in the chat if you had trouble, so I have an idea of how much to ask for. They should have those requests, so they should know. But the person who I work with on Access, she has to talk to other people, that the university books that sells the codes. Okay. Okay, so Felicia is saying that she tried a couple of times. Felicia, did you get the similar message that there's no availability?
No,
Oh.
I didn't get the message that it wasn't available. Well, I'm not sure if it was the message that it wasn't available, or I think I had maybe trouble registering, but it took me
Okay.
like 2 days to get through the process and be
Oh, okay. 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 Oh, thank you for enduring that. And I'll let them know as well, or if they can let us know any tips about how to do it much more seamlessly. So, all right, so we'll deal with the textbook issues this week. All right, so then are there any questions remaining about module 2? Anything outstanding that at the end of today, I can look at that? If there are, you can put it in the chat. If there's any pages you feel like were not covered clearly, or there's some outstanding questions you have. And if you're still working on it, it's okay. But we do need to move into module 3, and you should move into it. If you haven't started, you should move into it right away. So module 3, we have, oh, I have a photo question that I missed. Scarla, let me see what you have to say. Okay. Let me say 3. Okay, I'm gonna have to look at this after, but this is a very nice presentation. Okay, I kind of get your question. So is it a split stem? Do you have to do a split stem or just a stem and leaf? That's the question. So I'll look at that. So this is the stem and leaf plot. When you go by groups of 10, but then you can partition it, you can go in half and go by groups of 5 instead, intervals of 5. And the one that you should pick is the one that best presents the 5 features of the distribution. That's the one you should pick. So we'll review that.
Professor, regarding this exercise that I put in the forum, I have, I don't know, because if you scroll down the image.
Yeah.
Okay. I trace a line over the numbers, but I observed that it's even to the right, but I think that the answer is to the left, and or in this case of group 2 is symmetric, but the group 1 may I think that the answer is to the right, and I get confused if
Okay.
what I am doing wrong.
Okay. So we'll look at that. Okay, very good. I'll look at that. Hold on. Okay, well, thank you for the question. So we'll look at that in a second. So what you were supposed to do, everyone, is to download the notes, and they're in 2 parts. I should probably write part 1 and part 2. I don't know. I've never figured out how to integrate them because the samples are used throughout the notes, but I present all the samples in one document. So that's what it's like, a reference document. And then you have here, you have it in Spanish, you have it in English, and then you have here the annotated notes in English. You have the videos I asked you to watch, and then you have the page by page videos in case I missed something or you want to go deeper into something. So this is 3 hours and this is another hour. So 4 hours of videos. So maybe you didn't finish. And then you have the exercises here. And I think, is that in here, Carla, that question? No, not in the homework. Is it in one of the tareas?
No, it's in the tarea number 1, I think.
Yeah, right here. In the tarea. Okay.
Yes.
Okay. Okay, yeah, so this one and the cereal. Mm. Okay, we'll look at that. I will look at that after. All right, so what I'm gonna do is open the notes and ask you. Oh, Christina has a question about multi-stage. Okay, let me take Christina's question just to get it out of the way about multi-stage. What is the question, Christina?
Yes, it was from module 2 on page 20. If I was just the multi-stage sampling had some, let me go to the page. Where I have it.
In the notes, page 20.
Yeah, page 20 from model 2. Where it says okay, like the sample regions, they take SRS of 1/3 of the regions, and then they said the sample of the communities. We sample 20% of the communities, and then for the blocks will be 22%, and then for households 5%.
Yes.
I'm just asking, were those percentages for the example, or those the same percentages that we always get?
No, they're just for the example. They're invented.
Okay,
And
okay.
those would be determined by a statistician that determines if it's enough to be representative. So they come up with an estimate that will be representative or meaningful or significant. So yeah, so that's right. It's just for this exercise.
Okay,
And
that's
yeah, and it would have been in real life, it would have been determined by a technical statistician coming up with that.
thank you.
No problem. Thanks for the question, but it's a good question. Okay, I knew I could do that quickly. Okay, so back to the notes. Okay, so this is module 3, where we talk about distributions of data. So how to look at data and how to interpret what we're looking at. And we begin with a discussion about visualization. And I teach you with small data sets, you can make a stem and leaf plot. So I use this exercise here first, where we plot the data. There are 50 observations, and we plot them as a stem and leaf plot. And here, as Carla was asking, this is how we began, where we did a split stem and leaf. So what it means is, okay, so how many people do not understand stem and leaf? How many people do not understand stem and leaf? So I'll see how much time I'm going to spend on this. Put it in the chat. How many of you do not understand it? You have something, you're missing something there. What it is, what's going on? Okay, good. Let me know. Okay. Okay. See. So it's half of you. 1, 2, 3, 6. Oh, wait, half of you. 22. I'm gonna go to my iPad. All right, so this data the data here begins with $2.32 and it ends with $69.49. So that's about a range of like 65. You know, if I subtract the maximum, sorry. It's like 60. Whatever that is. What is that? $67. And these are dollars and cents. And there's 50 observations. And it just like, we want to present this data, but do we really need this detail in the data? We decide we don't need the detail and we just round all these numbers. So we begin rounding these numbers. When we round up if it's 50 cents or more. So this is $2. And this one is $7. And this one is $7. Okay, so we round. How do you say that in Spanish? So you round all the numbers. You could also just drop, you can eliminate the decimal places and you won't have much of a difference if you were to truncate or eliminate the decimal places. If you truncate,
Do you have to round up the number strictly based on the rules for rounding, or does
Yeah.
it have impact if you don't follow those rules strictly?
yeah, no, you follow the strict rounding rules. So if you round, you just 232 becomes 2, 261 because it's over 50 cents, it becomes 7, and 690 becomes 7. So that's what you would get if you rounded. If you truncate, you just drop the decimals. And really, if you're worried about your choice, if this, if you were not following instructions, you were doing this in your workplace or on your own, you would make both stem and leaves and see if there's much of a difference. Honestly, this really the decision of which graph to use is in your hands in the end. But there are some guidelines, and the main guideline is that you should be able to explain with a narrative story the 5 features of the distribution that you find looking at your stem and leaf or looking at your graph. Okay, so you ultimately get to choose. In this one, I gave it to you, but let's look at the stem and leaf below. And I also presented in the sample problems notes the stem and leaf if we did not go by 5, and we'll talk about that. But okay, so this is how we arrived at these numbers. So if I keep going, just to give you an idea, this is 8, this is 9, this is 10. Any questions about what I did there? So we're gonna work with these numbers. But as I said, we could also do these, and if we have a lot of time on our hands, we can make both stem and leaves and see that they're the same. If they're different, we have to make an executive decision. We have to decide which one we're going to keep, okay? But for now, I tell you, we're going to use the rounded one. So what I do then is I start noticing, you know, they're already in order. First of all, let me tell you the first step, you know, when we talked about, in the first module we discussed, or the last module we discussed labeling subjects or labeling units before we randomize, right? That was the first step, and the idea that all labels had to have the same number of digits. So that was the rule for assignment of labels. So what's the rule here? What's the first thing we have to do in this kind of a problem? It's already been done for you.
Rank the data.
Have to put them in order.
Rank, exactly. Okay, I just want you to lose that point because I gave it to you ranked. But yeah, rank or order the data. Okay, put the data in order. Okay, so then we move now down here. So I can see, I hope it's big enough. So I want to put, what my goal is to do is to put similar numbers together to see if there's a pattern. If I just look at the data itself, I don't get to see a pattern. I can, you know, I'd like to group together similar numbers, and I'm going to do that using the number line, really. And I'm going to divide the number line going from all the numbers that begin, the first digit is 0, have to be in this interval. So we're going to call these intervals classes. You can call them intervals, but it's often that you call it class. And I'm going to do it like this because I want to go a little bit slower. Okay, so I've eliminated the details of the centavos, the cents, but I want to see if there's any risk of losing any more detail. That's why I do it this way. I'm going to go slower. So I'm going to go by 5. So each of these, they have 5 possible numbers that fall in the class. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Okay, that's going to fall in there. So 5 possible. And then in this class here, it's also 5 possible. 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Okay, so 2 points. First of all, why did I use double-digit labels? Lisbeth.
Sorry. So you have 2-digit numbers because you have until 69, which is
Very good. Exactly. So there's n. Our n is 60. Sorry, our n is 50. No, I'm going to say n. Our last digit, our maximum, is equal to 69. It has 2 digits, so all the numbers have to have 2 digits to be able to make the stem and leaf plot, okay? Because the first digit is the first, is the stem. The first digit is the stem, and the leaf is the second digit. So we're going to group, basically we're grouping our numbers by the first digit, and putting all the leaves in the same class. We split them. Elizabeth, do you have another question or comment?
yes. In the case we have numbers that they are like 3 digits, we have to start in 001.
Okay, so if you're doing this on your own or you have another exercise, you'll have to decide. You could go with 2 digits in your stem and 1 in your leaf, but that would that means that it depends on your range of values. If all the variation or the difference, not the difference, but there's a pattern So if you can see a pattern doing it that way, that's different from doing it with the stem as the first digit and the leaves as the second digit. You'd have to make both of those and decide which one is better. So there's no real rule, honestly. It depends where, like in this case, the the pattern I want to see is in the second digit or the last digit. And that is giving me all this, this pattern here. And if you have any question, you're not sure, you would make both graphs to see. Now you're going to see if you're going to go by, if you're going to go with one digit and the other two digits here, that could be really long, right? But if there's not a lot of values or there's not a lot of variation, you can manage to see your pattern very easily. So it depends. Like I'm not going to say exclusively. There's some examples I took out of the problem set just to show you that there's no set rule of how to do this. It depends on your data. But if you're ever in question, just do it the two different ways you're thinking of and decide. Okay. In general, in this course, though, I'm going to tell you what to do. You don't have to choose for yourself. But that is the general approach. And I'm going to show you that here as well, because like Carla, was kind of looking at this and thinking, okay, and then she used this technique. Going by two is sometimes different than going by, splitting the group of 10 or the group of single digits into two is going to look different than if you put all the single digits in one class. All right. So did I answer your question, or
Yes.
is it okay? All right. So does everybody see what I'm doing here? So I'm going to put all of the zeros. I have to do it this way. So I'm going to pull these down. Not here. So here we have our numbers, our values, and I put 2 in there because it falls in the class 0 to 4. $7 though goes into the next one, and the 7 and the 8 and the 9, but then it's 10. Okay, so 10 does not fall in there. What happens next is that this first digit here has to be accounted for because it's not a 0. So we begin the next class. So the rule really is that this is just the first digit, and all the numbers, in this class have to have a first digit of 1. Sorry. Right? Any questions about what I'm doing? Oh, that's a 10, sorry. Oh, no, that's a 15. No, it's the one that matters. Okay, so that these are always the same for these two classes. Okay, and these all have 5 digits. So the thing is that the 1 is the same. Any questions? Let me check the chat. No.
I do have a question. I'm not sure if you answered it already. But if the case were to be that you have a maximum, let's say 100, then you will have the 2-digit stem and 1-digit leaf, right?
If that works for you, if that shows the pattern, yes. That's what I explained before. Yeah. Yes, you could have a 2-digit stem and a 1-digit leaf, but don't worry too much about questions like that, because I'll usually give you the instructions. I should give you the instructions, but essentially to see the leaves, this is where you're going to see, you're trying to group together similar numbers. And so if you had like 3 digits, again, the same question, would you put 2 here? It depends on the data set and where the variation is. So here you have some variation, but I'm grouping this variation together. I'm saying this is the same class. So these numbers are similar. This is the same class. So it depends how the numbers are spread out. But yeah, your intuition is to just put the 2 digits in the stem, but it might not necessarily be the case. I don't want to make a general rule. Okay.
I have a question.
Mm-hmm.
Does the range on the class has to be always for 5 digits, or it can be higher numbers?
As long as the intervals have an equal number
Okay.
of possibilities, and so the interval size has to be the same, it doesn't matter. It doesn't matter how you do this. So you could go by 2, you can go by 5, as long as it's even. So 2, 5. What else? Can you go by 3? No, right? Because it's not going to be even. So whatever you do to divide them, the same first digit has to be here. So yeah, you could go by 2. So again, it depends on, so if you have any doubts about your drawing, just make it the other way that you're thinking about and compare them. Okay, so let me show you.
Okay.
I'm going to compare this to going by 10. Okay, first of all, I want to make sure everybody knows how I made this. That's my first question. So did I answer your question, Sally? Yeah, Carla, I'll go to the skewness in a second. Okay, so that's why they repeat, because it's a different set of 5. It's the second group of 5, and then 5 and 5. Some people at first don't realize that 0, 0 to 0, 4 is 5, but there are 5 possibilities there. So I put them here. Okay, so 5 possible numbers fall. So the intervals must be, the classes have to be equal size. That's a rule. Okay. Sorry, my writing's messy there, but okay, I think you can read it. All right, so let's look. I want to show you. So if you had a chance to look at this, these are the solutions to each of the data sets, the questions I posed for each data set. So here's the one that we were just talking about. And this is known as the split stem and leaf plot, okay? The split stem and leaf plot. And I can say we're going by 5, okay? Because you could also go by 2. And this one is just called the stem and leaf. And we're just going by 10s. All right, so now we're looking at these 2. So this is what I suggested. If you have any doubts, make it either way. And obviously, if you have too much data, if you have much more data than this, if you're in the hundreds, you're not going to do a stem and leaf plot because it becomes just messy and it doesn't fit on a page. You're going to use another kind of illustrative tool, right? Like a histogram. So looking at this here, how do we analyze this? Which one is better? Which one should we
think
pick?
that the left is more organized.
Okay, it's
than
more
the
organized.
one.
How else do you describe the organized? How do you mean organized? Because this is organized too. It's in order.
Yes, but I think that on the
looks
left,
better.
It
It looks better. Okay, so
right.
you're feeling, that's good. No, it's fine. You
Mhm.
gravitate towards this because it looks like there's some information that's not here. That's basically it. You don't, this is like a mess. Like it's all put together. It means nothing. It's just like a big peak. Okay, it's an important group. It's an important class, but we're losing this detail. You're losing the pattern. You have much more of a story here to tell. Okay, so this is why we stick with this one as opposed to this one, but you can make both just to be sure. Okay. So another way to think about that a little more systematically is to examine the 5 features. What are the 5 features? So verify 5 features to make your decision. So 1, shape. What is the shape of this one?
Skewed.
It looks more
So it looks skewed. It looks
Right,
skewed.
cute.
Okay, so let's look at that. Let's talk about that because Carla wanted to ask that question. I hope I can answer.
Yes. For me, I observe it to the left, but I
It's
don't
okay.
know
No, I'm gonna
if,
go like this to show you. Okay.
okay.
If I move it like this, now you see the number line. This is left. This is right.
Okay.
Skewness is defined as having a few extreme observation in that direction. So there's a few extreme observations on the, Carla, on the right.
On the
So
right.
that's why we call it right skewed. Where the tail is, where the extremes are, that's gives it the adjective or the description. So this is right skewed because we have a few extreme observations on the right.
Oh, okay, okay. I just think that the major numbers or
Yeah, you're looking
okay.
here. It looks like no, I'm looking for the
Yes.
extreme observations, outliers.
Okay, okay.
And
I
it's
understand now.
a few extreme observations that create a tail. Yeah, I'm gonna erase it because it's taking my space, but you can think about that. You have to, it's funny because I've been teaching this class for 20 years or a variation of this class, and only because of iPads have I ever been able to spin my my histogram or my stem and leaf. So it's nice that I can do that. All right. You can see what I see.
So in the case that I don't have an obvious outlier numbers, it would be symmetric. Or if
Right.
the outliers are in the left, the shape is skewed to the left.
That's right. That's right. And the way you can see, outliers sometimes, a gap like this is a good indication that you can call these outliers, but I teach you how to check, right? You learn to verify statistical outliers, but this in vernacular, in the language, we can say this is an outlier because by saying outlier, I'm saying values that are moved or apart from the greater majority of the data. It's apart from the peak. It's away from most of the data. There's only 4 values out here. So we call them outliers, but then we can check to verify that statistically we should identify those as different and worthy of investigation, further investigation. Why are they there? What do they tell us? Okay. They're calling to us to investigate. All right, so let's see. Let's take a moment and let's look at the other one here. So what is the shape of this histogram? I mean, keep saying that, stem and leaf.
Skewed also.
It's the same, right? Or maybe not. So this is what Carla's talking about. Okay, they're all together and it's not really far, but the majority of the data is over here. So it's set apart, but it's hard to see. Let's be honest. It's hard. It's much easier to call these outliers than these ones over here. So and that's another reason we like the first stem and leaf, the split stem and leaf. So this is also, we'll just say that it's the same. It's not, it's different, obviously, but we would have the same conclusion that it's skewed right skewed. Okay, let's look at the second. What's the second feature?
The center.
The center. And what would we measure for the center?
It could be mean since it's not symmetrical.
So what's the rule? What's another rule that we have? So there's a bunch of rules that are going to be thrown at you in this module. What's the rule about center? It's in the big box in your notes.
Utilizar la data original.
Arisa?
Utilizar la data original.
Yes, that's a really good point. We have to go back to the original data to calculate exactly. Yeah, tenemos que regresar, using the data original. But yes, what would be the measure though? What would be the statistic we would calculate for center?
Using the median if it's skewed data.
Yeah, so depending on the shape, if it's skewed, which it is, we're going to calculate the median. Okay, different from not the mean. Without getting into all that, that's a rule you have to remember. Okay, so if it is skewed, that's why we identify the shape first, because the shape will tell us what kind of statistics to calculate.
If it's symmetrical, then we calculate the mean.
Exactly. Okay, so if it's symmetrical, we calculate the mean, which is just the average. The median does not require that you use all of the numbers in the computation. You're only going to use the numbers to make the rank order, and then you're going to find the number in the middle. So it doesn't use all the values, and it avoids putting these extreme values in your calculation. That's why we pick the median instead. Okay. And I'm not going to go detail right now about the median. I just wanted to ask you, what would be the measure of center on the second stem and leaf?
Median also.
Yeah, it's the same, right? It's not going to change. It's going to be the same. So these things are the same. So that's not an argument. The shape and the center are not arguments to defend one over the other. All right. Third, what is the third thing? Third feature?
Spread.
Spread. What is the spread? What would we measure for the spread?
Is the maximum is the minimum data.
And what else? One other thing. What would we do if it was symmetric for the spread? What would we compute?
You calculate the standard deviation and the mean.
All right. So for the skewed, you calculate what? So we do the range and look in your notes, range and five
number summary.
Summary. Very good. So if you didn't get that far, you have to learn that. Okay. So we calculate the range and the 5-number summary, and we just do the same thing if it was here. So that would give us the same values for the first 3 features. Where these graphs diverge is going to be, well, what's the 4th feature?
Gaps and outliers.
Gaps and outliers. So what would we say here for gaps and outliers? In the first graph. You see a gap in the first one. In the second one,
There's
you
no
don't see a
gap.
gap. Okay, so it starts to be different. And when it's different, you have to choose, right? And the fifth feature,
Single or multiple.
peaks.
so it's peaks, right? And in the first one, how many peaks are there?
One.
How
Tres
many peaks?
pisos.
¿Cuánto?
Tres.
Tres.
Three.
Exactly. You see 3 peaks. So there are 3. And how many in this one?
Two.
Two.
And you could argue that is this even a peak? You wouldn't even know what we could even just draw it like. Well, both of them we could draw differently. We have to choose. We could just say like it's like that, not a peak really. If so, what does it mean when I smooth out the curve? When I smooth out the curve, I can smooth it out in different ways. What am I thinking? I'm thinking if I had more data, it would fill in this gap here would just fill in. This is just this is not really a peak. If I want the blue one to be my, my histogram, I don't see this as a peak exactly. I just see this as a smooth curve with a little more weight over here. Okay, it's not really a pattern. That's what I'm saying. But if I go with the green one, I'm saying that if there was more data, it would sustain, and this peak would be a little bit higher with more data. It's just a matter of not having a lot of data. So the choice of these depends again on your understanding of the data, of the phenomenon. Maybe you need to get more data to be clear which one you would pick. Similarly here, you could argue but still it's going to force me to do this. There's something happening way out here that I don't want to ignore. This would be the strong peak. This would be some other phenomenon over here. You could call it a peak that's worthy of investigation. Again, it's like our outliers. So which one you pick, yellow or red, again, depends on your story. So we ended up going, in my explanation, I picked this one. I picked the yellow on this graph. And I tell
But
the story.
in any of the scenarios, though, left side provides a higher degree of detail, right?
Less, say that word again, less.
The left side provides a higher degree of visibility to the data, right? Because
Yeah.
you can see in either scenario, you see more peaks on the left than you see on the right. So
Well, it's an interesting way you said that. So the most of the data is over here and it describes most of the data, but that doesn't diminish the value of what's happening over here, worthy investigation, because this is a lot of money. You get more money over here than you get in most of this. Okay. So this is worthy. This is important too, but it's a different phenomena. That's what's happening over here. These people are going in and buying. This person spent $2. They bought a pack of gum. I don't even know, but maybe gum even costs more now. They bought a few things here. They got a few details, but these people either went grocery shopping or they have more money and they can buy more, or they are commercial. They are other businesses that are buying products that they're going to use, inputs to their restaurant or their whatever they're serving, their a catering service or something. So these might be other businesses walking in the store. I don't know, but this makes it worthy of investigation. But yeah, this is describing most of the customers, but depending on your data and the context, in this case, these people over here are important, but these people are just as important. And even though there's just 4 of them, we're interested in those because those are high-paying customers. We want to know what they buy and why and what other products we can offer to them so they spend more in our store. So here, my description, my choice is this one with 3 peaks. And I tell a story that maybe this is low, middle, and high income groups. So maybe that's what it's about. Or I also mentioned that this could be a whole different customer. That might be a retail, a commercial customer, another business that's coming in. All right. So The conclusion here is by doing the 5-number summary, you can, in a systematic way, evaluate or assess the stem and leaf that you made, and then make a choice based on it and any story you can tell. In the second one here, I didn't finish peaks. I think I said there's 2 peaks or 1 large peak. How did I say it there in the notes? It's down here. Oh no, it's on the other. It's in the videos. So just one peak, 1 large peak or substantial peak where most of the data is, and then a second smaller peak. And you completely, you miss the second group. Even if I divide this as low, middle, and high income classes, your low income, there's more people low income buying just a few things. It depends. You'd have to go and look at your demographics in your area of this grocery store, who they are, and then what they buy. And that could be all data that you have. Okay, any questions about this? So the answer to the question, which one do I pick and why? I use the 5-number summary to differentiate them and say, okay, there is a choice to be made because I have different results, but I'm going to choose this one because it has more, it captures more the exact detail that I want, not excess detail, but it shows a pattern, and it makes me wonder if, I'm going to do some more research to see if this group can just be combined with this other group. And then we have this one here. This doesn't show in the second graph here. It doesn't show that second group that we want to investigate. All right. We're good. Comments? So you can see the right skews. Okay, let's look at the serials, the serial question. Okay, Inaru. Question.
I have a doubt in terms of how you like decide where the peaks should be. Because I see that like you did like a more smoother line on the outside, but when we're doing exercises like this, how do we decide like what's the best option?
Well, again, you have to defend your choice.
Okay.
Basically, that's my answer. If you're going to choose, so the smoothing is to say, if I had more data, I believe the pattern would look like this smooth curve. So what I'm saying here is, I believe that these people are all the same.
Okay.
Customers, and these are other businesses buying some expensive products or coming in to get to get things for their service that they're providing. But these are all the same. So if I use the red, that's what I'm thinking. And maybe I even might as well go with this drawing here in the green, right? But I have to make that decision. I know my customers, they're all kind of the same. There's no difference in the groups. So
Okay,
you
like
have to choose and defend.
In the test, we would just have to like write that, like, oh, I just think that these
Yes, I think that's just this. I don't think this is a distinct group. I think they're just the same. With more data, I would see this fill in and be this red curve instead.
Okay, and then like you chose to put like the lower part because there was no number in that second 5, right? So that's why like you choose where
I like this because it makes a nice distinction between the outlier class and everybody else. It's really nice and clean. Here, you're getting, someone could come and argue, oh, it's all the same, just put them all together.
Right.
And say it's symmetric. With more data, this will fill in. That's basically what it is. When you're making the curve, the argument is, I believe if I had more data, it would just look like this. So I refer to that as the idealized version of the data.
Okay, thank you.
And you smooth over the data. Smoothing. I'm creating I'm gonna say smooth. It's funny. It's funny questioning my terms. Okay. All right. So you'll see that again. I do that a lot. All right, let's talk about the serial. The serial. Let me get out of here. Any more questions on this? I'm going to escape here. Oh, gotta close here. All right. Okay, the serial. So this was from Tarea Uno, right?
Yes.
Tarea. And let me see my clave for this. Oh no, again, I'm going to look at your question because you have more drawings for me to look at. Okay, so this one. Okay, so this, right. So if you do this as a split stem and leaf, you will get a certain drawing, but this one is, you don't want it too flat. You want to be able to see peaks. You want to see grouping of data. You're looking for patterns. You're looking for regularity and curiosity. I think I picked this as symmetric because it's a very small data set. You have most of the data in the middle, and then you have 2 on the left and 2 on the right. Now there is a gap here, but you could argue, right, that with more data you would fill this in. So if you did another, what is this about? So if you added 2018 sales, you would see the pattern would sustain itself, and there'd just be a little more data in there. Is that okay, Carlo?
Yes, yes. I just clarify my doubts. Mhm.
Okay, good. And then here you understand, right? The
Yes,
left.
yes.
Okay. Very good. Okay, good. Thank you for the drawings so people can look at her drawings. All right. So what else should we look at? So how far did people get? Oh, I'm on the wrong one. How far did you get? So people who worked on this, how far did you get in the notes? Tell me. So you understood the mean median, center spread, my discussion here then of spread, talk about peaks and gaps and outliers. And then I began with the calculator, okay? Now these videos, this links you to the old videos, and I use a different calculator in the old videos. So I don't know if you want me to discuss the calculator right now. We can do that so we can clarify how we're using the calculator. I'm going to use it, well, we're going to use it for this module, module 3, and also module 5. I'm going to lean on the calculator a lot. Did you get this far about the standard deviation and how to calculate it? I taught you how to calculate it in the calculator. So we can talk about the calculator, and then we can I spent some time explaining this formula.
I use Excel for those calculation. Is that okay?
You can use Excel and it is okay for this class. Yeah. In my presencial class, I make them get the calculator and use it for the test. But yeah, for this class, because it's distance, you can use Excel. I like the calculator myself. I have the calculator on my phone and it's always with me. You know, Excel is not always with me like so that's why I prefer, I want you to be able to do both, you know, but if you're fine with Excel, I'm not going to make a big deal. I'm not going to find out if which one you're using. I'm not going to ask you. In the course, in this course, in the exams, if you use Excel for data computations, you have to send me the Excel file with the formulas. So you have to send me the Excel worksheet, not a PDF, not a picture, nothing like that. I need the Excel worksheet. So you'll have an opportunity to upload that. So that's okay. If I answered your question. All right, let me show the calculator. Okay, so what we're going to do is we'll look at this data set here. And please watch the video about what this formula means. It's very important that you understand this video, but I'll show you the calculator. Do you have a question? Someone?
Yeah, the Excel that we're talking about. When you say the formula, so we just can't use the median formula that Excel gives us, right? We need to do basically all the.
No. When I say form, what I'm saying is, no, you don't have to do all the tables. No. The tables are not necessary. I'm just showing you the table and I'm teaching the table so you understand this business. Like, what does this mean? That's my importance. I don't really care if you can get the number. I want you to understand what this means, because statistics is really about averages and relative measures. That's it. All the statistics we calculate are some sort of notion of average. You know, how we put these numbers together, what is, because we're trying to figure out what's predictable. Want to know what to expect. And we do that with expected value. And so really it's just a bunch of averages. And so we start with the mean here, which is, this means sum. This is a Greek letter. It says sum up all your observation. This is the symbol for each observation. And this labels them observation 1, observation 2, observation 3, all the way down. And then you divide by n. That's what this means. This is an average. Whenever you see this symbol, you're working with an average. Here, believe it or not, this is also an average. Now, it looks different than the one on top, but it's an average. If you accept that this is just like a calculation of x that you make. So it's like this. So this is the same. This thing in here is like equivalent to this over here. Just ignore the square. I can't highlight the way I want. Yeah. Okay. So with the square, it's like that. And so there's the summation. And then this is the averaging feature. You divide by how many there are. So you're giving equal importance or significance to the observations. Well, you're doing the same thing here, but less one. And I explain that this is a result that you have to go one less because you need to make the denominator smaller. When you make the denominator smaller, you're making the overall number bigger. What number are we talking about? We're talking about the measure of spread, how spread out the data are. So we want to be able to capture the data, describing the data with the statistics. So when we talk about the 5 features of the distribution to describe the data, the 5 features replace the data in so many words, right? You don't present, when you write a report, usually you don't put pages and pages of data in your report, right? You just present the 5 features of the distribution, you make a few calculations, and you present your your conclusions of your 5 features. What did you find? All right, that's how we work. Now, part of the 5 features are the center and the spread. Okay, those are 2 out of the 5 things you're going to talk about. So those have to say quite a bit. So this exercise here, let's take the calculator. I'll take the calculator and show you how I do it on the calculator, but it's really important that you watch this video. I won't reproduce it here because, well, how many people watch the video on this? Put it in the chat. I want to see how many of you watch the video. You don't have to lie. Just tell me the truth. Because if you didn't watch it, we'll review it. But I want you just to watch the video because it takes half an hour. And I don't want to take that time from our time together. Okay. Okay. Oh, what did I ask? I asked who did watch it is what I asked, right? Who did watch it? No, just tell me if you did watch it so I can count. Who did watch it? 1, 2, 3, 4, 5, 6, 7. Okay. This is a must. All right. Don't dismiss it. Don't just make the calculation in Excel, not to discredit, people who just did that because they understand it. I need you to understand this formula because I'm going to refer to it a lot. Okay. Make sure you watch it. Okay. Today. What I'm going to do right now is use my calculator to get the values. And we are going to, this is page 10. I'm going to use my calculator to get the values and we're going to interpret. I had this discussion with student in my, this often comes up every semester. Some student says, oh, why do I have to know all this? I just have to interpret the data. I disagree. You need to know what is inside of the black box. You need to know how it's manipulating the data because that avoids like really bad use of statistics. Okay. So I've had in the past doctoral students come to me with an analysis they did with output from a computer, and it makes no sense what they just did on the computer because they didn't understand the nature of their data and they just put it in to get some numbers. Completely useless. You need to understand the nature of your data and you have to understand what a standard deviation is and does because there's options to measures of spread. There's alternative statistics. How are you going to choose between your statistics if you don't understand what they're doing? Okay. So I'm putting my foot down that you guys have to understand. In this class, at least, this class is reserved for the fundamentals of statistics. So let's learn the fundamentals. I want to say just something about Excel first. When I talk about formulas, what am I talking about? Let me be clear. I'm going to project my Excel sheet here. All right. So when I talk about formulas, I mean, okay, let's do this. So I'm just going to put the numbers down that are in the example we're going to look at. I put them in the wrong place. So let's go here. So this is observation 1, observation 2, observation 3, observation 4, observation 5. I just use that for a label, right? This is a label to put them in order. Now, if I want to get the average, I use an equal sign. Now, this isn't in English. In English, you use an equal sign. I think in Excel, in Spanish, you use an equal sign. But if you're going to do this in different languages, you have to follow the convention of the software you're using. I don't think it's an equal sign in every language, but I think Spanish and English is equals. So then you say, sorry, equals, and you say average. So when you start to write average, you get a drop down. So you can choose here, and then you have to highlight the values and close your bracket. So when I talk about formulas, what I'm talking about is this. When you send me the file, send me this file so I can see what formulas that, you used. So that's what I mean, formulas. Okay. If you want, so this is the average or the mean. It's the same word. And the standard deviation. Standard deviation is here. So I'm going to do the same thing. Equals standard deviation. And be careful with Excel that look how many different standard deviations there are. You got to know which one you want to use. You got to know which one you need to use. That's the one I have. Okay, so those are my results. 8.2 and 5.31. I have the formulas programmed here so that I can show somebody how did I get that? Okay. So when you send it to me, don't send just the results. I want to see the Excel document.
So my question was, because on my analytical chemistry lab, we did this, but we didn't use the standard deviation formula that Excel gave us. So we kind of went from taking the xi or the observation minus the mean, and then that will be on the C column, and then on the D column that will be the square of that, and then on the other column then we add the
Yeah,
n.
very good. Yeah, so that's what I'm illustrating here in the notes.
So what
But you
we
don't
did,
have to do that in Excel for this class. No.
okay,
That's why I wanted to clarify. So this we're only going to do once, and you're going to refer to it if you ever forget how to get the standard deviation. So the point of this exercise is to explain to you why we do this. For the people who watched this video, what did you learn? What were the highlights of this explanation? What were the highlights? What did you learn? What were the highlights? There's like two main things to learn about it. I'm making it like it sounds some amazing thing people missed, but what were the highlights? You can speak or you can text, chat.
Entiendo que la fórmula de variación estándar es la varianza, que es un dato importante.
Yes, very good. So the standard deviation is really the square root of the variance. The variance is the most important thing, that this is the variance. And what is the variance? The variance is an average. So the standard deviation is the square root of the variance. The variance is an average. It's the average of the square deviations from the mean. And why do we take the square root? Do we take the square root because we square the deviations? And finally, why do we square the deviations?
To determine the range.
No.
to decrease the errors or to minimize,
No.
to remove the negatives.
There you go. Exactly. I knew you were close. Okay, so we square, so people who watch, these are the highlights. Okay, so Aritza, Patricia, and sorry, I didn't get your name, but I'm learning your voice. Who was speaking before? Was it Habla otra vez? Emmanuel fue? No? Who was speaking? El hombre.
Misael.
Misael? Okay, Misael. That's right. I thought it was you. Okay, so all the points that you made, we want to remember that this is a deviation. Sorry, that we want to remember that, like Aritza said, this is a variance, and we're taking the square root of the variance. What is the variance? It's the average of the square deviations from the mean. Why do we square? We square because really, if we could just do the deviations from the mean and average it, that's what we want, right? We just want to get the deviations from the mean, because that's what we're doing, the deviations, right? How spread out are the values around the center. The problem is because of what a mean is. The definition of the mean. What is a mean? What is the definition of a mean? The mean is the center of gravity. It's the center of gravity. It is the value closest to all the other points. So if this was if I wanted to build a house and I wanted to be close to the school and my work, I would go in the mean distance between, because that's closest to both of them. Okay, so the mean is the center of gravity. That's if it's symmetric. In this case, the mean is going to be, so I can't talk about it as distance that way, but in terms of volume, the mean balances the volume. So if it's not symmetric, it's skewed, it's actually balancing the volume. By balancing the volume, it's still, that's still notion that it's balancing point of the data. It's closest to all the values. These ones are spread out though, and these ones are more compacted. Okay, it's the center of gravity. So because of that, when I take the deviation, if there's a value over here and I subtract the mean from it, this is going to make a negative on this side. I know this is the mean. Why do I know A is the mean? Why do I know A is the mean? How do I know C is the mean? How do I know C is the mean here?
She's in the middle.
Closer to the
It's in the
center.
center of
In the
gravity.
center.
No, that's not why. So in this drawing, I explained in this drawing that, okay, in this drawing, we have what's called the mode. And here on C, we have the mode. Then I made two other lines here to distinguish that the median is between A and C. C is the mean. The median will always be between. Over here, A is the mean. B will be between. This is the median. The median will always be between. The mean is always closer to the tail of extreme values than the median because of what it is. So this is why it's really important to understand these terms. The mean uses all the values in the calculation, right? Every value, sum and divide by the number of values. So it's going to be affected when there's an extreme value. It's going to be closer. The median does not include every single value in the calculation. All it does is it finds the center values and it averages the center values, or it is the center value. It doesn't compute using the extreme values over here. But the mean is affected, so it's going to be closer. Same thing over here. The mean is affected. So here the mean is C. It's closer to the tail. All right. So the mean is the center of gravity. It needs to balance the density, the area on the left with the area on the right. That's why when we're looking here on this, trying to balance, where's the balancing point of this shape? It's going to be here. It's going to be here to balance this length, this density, all this shape here, volume with this one here. This tail balances with this weight right here, and that is the mean. Okay, it's a balancing point. It's a center of gravity. As a consequence, when I calculate the deviation from the mean, the values going here and their distance will be negatives. If I take the value minus the mean, will be negative on this side. They'll be positive on this side. And what happens when I try and calculate the average, where is it? What's up here? Where is my exercise? Oh, yeah. Here. When I try and make, like Patricia was describing in her chemistry class, when you take the mean from each value and you make a column and you try and finish your work and say, I'm just going to get the average of the deviations. Sorry, I have to turn somebody's microphone. Okay, when you have to get the average of the deviations, you're going to have a problem. And what's the problem, Maritza? What's the problem, Patricia?
The negative values.
No. Well, no, what's gonna happen when you sum these?
We're gonna have both positive and negative values
And they're gonna sum to what?
to an ever, right? That's
Zero, zero. They're gonna make zero exactly, okay? They're gonna make zero. That's why we have to square, because we have to remove, like you said, the negatives. We have to make all of them positive, and like Misael said, we have to retain the magnitude. I think that's what he was intending to say. And we maintain the magnitude of the distance. We don't care if one's positive or negative. All right, so this says a lot here. So then what we do is we average this. But one catch is we don't average dividing by n, we average dividing by one less, because it was determined that you would be, because this is not, so these measures are statistics, right? I'm taking the data, I'm calculating the mean, then I'm using the mean inside here to calculate S. There's a problem with that. The problem is that the mean here is just the result of a sample. And I'm not considering like the data that I didn't get. Okay, there's data missing, right? There's more information I didn't capture, but I just have a sample and I'm going to work with it. So I have to be careful when I use an estimate inside of an estimate. I want to adjust for the fact that I could be off. And now what we want to be able to do is describe the data. So what I'm going to do is let the spread be a little bit bigger. I'm going to let it be a little bit bigger. I'm going to take off 1. I'm going to use not 5, but I'm going to use 4. I'm going to divide by 4 instead, and that will ensure that my spread is a little bit bigger. And I'm going to show you why. We're going to talk about how I'm going to use that in my interpretation very briefly. Okay, did you follow me so far? So this says a lot. This is like a summary of so many things. You need to know what a standard deviation is. The standard deviation is the square root of the variance. The variance is the average of the squared deviations from the mean. It's a measure of the spread of the data, the volatility of the data, and the predictability of the data, okay? The predictability of that variable. If you have a high standard deviation, it's hard to make a good prediction. Right? You can't just pick one number. It's going to be more difficult. There's more variation, there's more volatility. Okay, so let's look at, does anybody have any questions for me? What did I say? Oh, I wanted to do this calculation on my calculator now. I don't want you to forget anything I said. If you have to review this video, and please watch the step-by-step that Patricia, she did it in her chemistry class, so she knows. So what do I want to do? I'm going to open that file. And see if you can see this. Great. Okay. So let's put this data in our calculator. So let's get our calculators. I use the TI BA2 Plus. If you have another calculator and you don't want to buy this one, it's fine. But if you have the money and it's not a big deal, you can put it on your put it on your smartphone, or once you buy it on a smartphone, it will go to your tablet that's linked. So you'll have 2 versions. It's like $16. Otherwise, if you have another calculator, you have to show yourself how to do this, and you can find a YouTube video or you can figure it out once I show you this. So what we got to do is turn our calculator into statistics mode. And we begin by entering data. Everything starts with data. So we're going to hit second and data. So now I'm in the data sheet. And then I start to enter my data. I'm going to begin with this data here. 2, enter. And I scroll down. Is everybody with me? I don't want to lose people. We're trying. Okay, so if you have another kind of calculator, look for something that says stat mode or data, or it has the sigma symbol, that the E symbol that we're looking at in the formula. Okay, this one here, something that looks like this. And turn that on and start entering data. Now this calculator performs 2 variable statistics. So I can enter data in pairs. When we're going to learn about observation pairs, really that's for analyzing 2 variables at the same time. So far, all we're doing is looking at 1 variable at a time. Okay, we're looking right now at spending money. So money in a student's pocket for buying a coffee for himself, buying coffee for his classmates. All right, so now this is why I have Y here. Y is for the second data set. So the first data set is called X. The second data set will be Y, but we don't have that here. So we're gonna continue to scroll. We're gonna get X2. So now I'm gonna enter 8. 8 is my next value. Enter and scroll down and skip over this X, the Y, back to X. Then I'm going to enter 10, enter down, down, and 16, enter down, down, and 5, enter down, down. And I can review my numbers. 2, 8, 10, 16, 5. So anyone who's doing that, you're okay? Got it, Jose? See a few of you. Now I'm going to ask for my statistics. Second, stat. And it says LIN. What does LIN stand for? Does anybody know what it means? LIN. Short name. LIN is for linear. Because you can enter 2 sets of variables that you want to relate or determine the relationship between them, you're going to first look in this calculator for the linear relationship between them. In other words, can I use one to find the other? Are they related in such a predictable way? What is their linear relationship? So we're not doing that right now because we only have 1 data set, but let's scroll down. We're going to use the arrows to see the results. There's N observations, so we use the symbol N, right? For samples, we use small n. For population, we use large N. This is the result. What is this?
That's the mean.
That's the mean, $8.20. So we have to interpret that. And next, scroll down, we have SX. SX is the standard deviation. Let's keep scrolling, see what else we have. Uh-oh, what's that?
The variance?
The population standard deviation.
Close. Yes. Yes, you said it the second time. It's the population standard deviation. So let's be specific. This one is the sample standard deviation. That's the sample standard deviation. This corresponds to the formula we have on the page on our notes. But the calculator doesn't know if you want to calculate it as a sample or if you have all the data. It's possible that you're conducting a study and the data that you have is all that exists. You have the full population of data. In that case, you would use this number. Notice the number is smaller. Why is it smaller?
Because you have more numbers, more observations.
No, it's the same data set. I didn't enter any extra data, but there's something, not the observations, it's something else, you know. Let's see. The issue is when I ask for the sample standard deviation, it calculates like this. If I ask for the population standard deviation, how does it calculate? It thinks that I entered the population, so it uses the N as though it's the population and the population size. And then the symbols, this is in the notes. You don't have to copy because I put it there on the other pages, but I'm putting it here, right here, so you can see it. So what changes? Because I have the population of data, I interpret my sample mean as the population mean. I use the symbol M in Greek letters, is mu. So the Greek letters kick in when I have the population. That's how we differentiate, okay? If you see Greek letters, it's the assumption is that that is the population information. So if we have the population, then I'm going to calculate the population mean. Notice I use a big X because it's the population observation. The small x is for observations that are in the sample, not all the values, okay? And we use large N. So why is it going to be, in our problem, it's interpreting, so this would be 5, but over here, this will be 4. So this population standard deviation will always be smaller because you're dividing by a bigger number, right? So which one do we use? We always use the sample unless someone tells you this is the population data, or you know that this is all that exists, that there's no other data to collect. Okay, you have the population. So you're always going to go for the little bit larger. What is the advantage to that? I'm going to show you now. Okay, I'm going to show you how we use these values and why this has to be a little bit bigger. So if you ever go on in statistics, or if you study statistics at a higher level, you'll know, or you'll learn about how this, because we -1, this is known as an unbiased estimator. It means that although we took one sample and calculated statistics for the sample, we could take another sample. We could have had another sample, right? And the statistics would be different. They could be the same, there's a chance, but they would be different. Or we can get a different sample with different values. But overall, if we did that as many times as we could and collected all possible samples and calculated the statistics from all those possible samples, on average, if I average all of the sample standard deviations I calculated, on average, I would get the true population standard deviation. If I could average them, I would get this. Now, we can't do that. It's a thought exercise, right? We don't do that. But theoretically, it's what we imagine, and it has been empirically tested. Statisticians have tested that. That would happen. If you had a label population, and they actually did this with computers, they create a population and then they sample from the population repeatedly, very quickly with a computer, they write a program, and then they average the statistics from each sample, and the average ends up being their original population standard deviation, or the population mean. This one here. All right, so I've said too much information probably, but don't worry, I'm not going to test you on it. I just want you to understand what you're getting out of your calculator, because this is just a very simple exercise where I show you a student who doesn't understand the difference between S and sigma will pick the wrong one. And in certain industries, it will matter because the numbers won't know, it's not life and death, but in other industries, it could be a life and death issue, picking the right one. All right, so what I want to do now is use the mean and standard deviation. How do we use those to make a statement? So what did we have here? Let's recap what we have here. Below is the pocket money spent by a student for lunch and snacks over the past week. How much money can she expect to have in her pocket in a given week? So I'm kind of insinuating, I want to predict how much money the student will have in their pocket based on how much they spend. So maybe I work at the cafeteria and I want to have products, you know, for them to buy, the student. I want to expect also how much can I, how much of an inventory should I have given what the students has spent before. So, okay, this is not a great study. I'm only studying one student, but whatever. I have limited time to do this. So I'm going to do this, let's say, with the data from one student. And I get that the mean is $8.20. So she spends about $8.20 a day. And I say, give or take $5.31. So let's put that in numbers here. So $8.20, give or take, is plus and minus $5.31. So within one standard deviation, so within one standard deviation, what proportion, what percentage of observations are described? So what you have to do is make an interval. Add and subtract 531. What is the interval? What is the lower bound on that interval? And what is the upper bound? So 820 minus 531. What do you get?
It's 289.
$2.89.
And the maximum is $13.51.
Does everybody agree with those calculations? Okay, now answer the question. What percentage of observations are described?
I would say about 60%.
Well, let's count. Let's count. Let's see. Is 2 in that interval?
No.
No. Is 8 in the interval?
Yes.
10?
Yes.
Is 16?
No.
No.
And 5. So we get 3 out of 5. How many is that? What percentage?
60.
60.
Very good. See, Michelle is right. Okay, so it's 60% of the observations are within one standard deviation. In general, there's actually a theory, I think it's Chebyshev's theory. Within one standard deviation of the mean, you should find the majority of the data. This is a greater majority. This is more than 50, right? 60%. So that's why we need the standard deviation. We work with the mean and describe without showing all the data. Remember what I told you, we don't present in our report all the data. It could be pages and pages and pages. Obviously for this one, it's not a huge data set, but in general, I use small data sets so we can make calculations in class very easily and less tedious. But in general, you want to simplify for your readers, right? So you say, within one standard deviation, we have 60% of the data. So we look at this and he spends between 1089 and 1351. So that gives you an idea of the range of spending. With regularity. Again, obviously you can see the range with 5 figures, but if you had pages and pages, hundreds of data points, you need a way to summarize. All right, so what about, and this captures, describes 60% of the data and the regularity of that, right? All right, so what about 2 standard deviations? What if I calculated
Professor, to understand, what is the importance to perform once, or select one standard deviation or two standard deviation versus three standard deviation?
Well, let me finish the discussion. And then
Okay. Mhm.
okay, so let's see. With two standard deviations, give me the interval.
Ahora.
So what would be the interval with two standard deviations?
Is it negative 242 and 1882?
Yeah, looks like that. Okay, so mathematically, this is the interval. I keep putting the units in, right? Mathematically, this is the interval. But feasibly, he's not going to have negative dollars, right? So how many data points does this capture? Two standard deviations.
Captures all the observations, right?
All the observations are in here, right? This is 100% of data in this interval. So what does this tell us? It tells us that the data is it's very tight, right? The data is within two standard deviations, you have everything. So remember, the higher the standard deviation, the more spread out. But this using the standard deviation, within two, we describe the full range of the data. The way that we're looking at this distribution, we're not talking about it in any particular way. We did make an assumption, though, when we did this. What is the assumption that we made by even calculating the mean and standard deviation? We made an assumption. What assumption did we make? What did we learn at the beginning? If data are skewed, data are symmetric, that's going to determine the statistics we compute. But right away, we went and calculated the mean and standard deviation. So what were we assuming?
We're assuming that it's symmetric.
Yes. Now, it's weird. We only have 5 data points, but that's implicitly what we're doing. We're assuming the data are symmetric, and we're going ahead and calculating mean and standard deviation. In other words, don't just go and calculate the mean and standard deviation when you have data. Plot the data, look at the data, and then decide. You have to get the shape first, okay? Some people just want to get statistics right away. What you could do to determine the shape is get the statistics, but then do an analysis like I mentioned here. What did I say here? How could you use this discussion here to help you decide if a distribution is symmetric or skew? You could calculate the statistics, and if you see that the mode is less than the median, is less than the mean, then it's right skew. So that's if you don't want to draw anything and you just want to get statistics, that's how you can do it. But they have to be, I would still encourage you to draw it because you have to see the distance of difference. Like you want to see how spread out they are, right? So if it's like this and there's a distinct difference between mean and median and mode, and the mean is larger than the others, then you have a right skew. On the other hand, if the mean is smaller than the others, then you have a left skew. Okay. So you could use statistics to do it, but I prefer to recommend, or I prefer for you to draw them first. Okay, so this is telling you about the regularity of the data, the predictability of the data. Within one standard deviation, you have 60% of the data. Within two, you have all of the data. So, I mean, again, it's a very small data set, but it tells you how predictable it is. If you have observations outside of 3 standard deviations of data, you have a very spread out distribution. And in fact, the data that's outside 3 standard deviation is known as outlier data. Okay, you have outlier data. So that's something that I mentioned as well. I'll just make a note here. Are there any outliers in this data set? Are there any outliers?
216, right?
No. Look at my definition here.
Oh, there aren't any.
No,
Outliers, because we never got outside 3, okay? Only if you're outside 3, there are none, because all of them are within 2. There's nothing beyond 2, so we're not that far out. So there's no outliers in this data set. No extreme values. There's no outliers. The reason why, so somebody was asking, why do we do this? I think it was, oh, I'm not sure. Sally, who asked me?
Carla. I
Carla.
want to know, yes, I want to know the importance of selecting 1, 2, or 3.
Okay, well,
standard
usually the
deviation.
pattern is to just, well, to get the standard deviation first. So it's possible to make all those calculations, but it helps you identify if there is a particular shape of the distribution. So we talked about parametric statistics. Okay, I mentioned parametric statistics. If you've learned statistics before, you learned about the normal distribution. The normal distribution is introduced to students and scientists because it is it's actually a distribution that was developed by statisticians to help make predictions. It has a specific pattern, and if you can say that a data set is normal, then you can use all the programming tools that are available, because normal distributions tables exist. Excel has a normal distribution programmed in it, and it helps you make predictions if you know the pattern of the data. Okay. This is here, this data I've given to you is not parametric. It's just a data set. I didn't tell you it has a specific shape or anything. We're just going to use it to, we're using it to make calculations and some idea of prediction. We're saying, most of the time he has between $3 and $14, but he never has more than $19. He never has, he never has more than $19, I guess. So that's important information, but that's it. That's all you got. You don't have something like a normal distribution that helps you make predictions and that you're leaning on. So what is a normal distribution, for an example? I'll tell you. So a normal distribution has a pattern. It observes the 68, 95, 99.7% rule. So it says that the data is distributed so that 68% of the observations are in one standard deviation, 95% are within two, and 99.7% are in three. So within three standard deviations, you see almost all the data, but this leaves room for outliers. If you have a data set and you see checking the 1, 2, and 3 standard deviation, that it has almost like this pattern, 68% of the observation, just like we did here, we found 60 and here we found 100, okay? You're gonna check after you calculate mean and standard deviation, after you look at the shape and you see it's kind of smooth and symmetric, and you see this pattern, you can then say, I assume not just the data are symmetric, I assume the data are normal. This makes it special. We can use the normal distribution, and that's going to be in the next module 4, right? We're going to talk about it. But then you can use the model, the normal distribution model, to make predictions. And again, predictions are only as good as your the data you put in or your assumptions, right? And we can assume it's normal. We'll say that we want to find out what's the chances of certain things happening and depend on the normal distribution to do that. And it allows for some extreme values as well. So the question to you is, even if you didn't understand everything I said just now, is the data here, the spending data, normally distributed? Put it in the chat. Do you think that this data here has a normal distribution, the spending data? Does it have, not spending data, this is called the pocket money data. Does it have a normal distribution? You can say yes or no. So you want to assume that this data is normally distributed? Let's review. This data has 60% of the observations in one standard deviation. The normal has to have 68. Okay, well, you could say it's close. It's kind of close, maybe. This two standard deviation that has 100% of the data. You could say, well, that's like 95. But then you have no data. I mean, within 3 standard deviation, you also have 100, but this is distinct. And we have no outliers. So I would say no, it's not normally distributed, but you guys making a reach for normal distribution, I mean, it's not terrible. I guess it's not a terrible thing, but I would say no. I would say no, it's not normally distributed. I would have to get more data to check. That's what I would do, okay? So I would say because there's no outliers, normal always specifies there needs to be some outliers, and we had none, right? That's the problem. That, I mean, that will be our clear. It allows some outliers. So let's see, if let's say the N, you had example of an N with 10,000 observations. How many outliers would there be if it was normal? How many outliers would you have if you had 10,000 observations? How many outliers should you have approximately?
$30.
Excellent. So you're going to take 10,000 times times 0.003, right? And you get 30. So with 10,000 observations, there's only 30 outliers. It's possible we can't see outliers. We don't have a lot of data here. It's possible. It's possible. You guys, you guys are convincing me that maybe it could be normal, but I need more data. But as it is, I won't put the stretch out and say it's normal because I don't have enough data to prove that. But just giving you an idea. Okay, do you guys understand what I'm saying? You guys follow what I'm saying here? So when you get data that you don't know the shape, you don't know anything special about it, you calculate, you make the shape, you look at the distribution, you graph it. Then you, based on the graph, you calculate the relevant statistics. If it's symmetric, you get the mean and standard deviation for center and spread. If it's skewed, you get the 5-number summary. And then with that, you do your 5 features of the distribution analysis. You can also check if it has a normal distribution. And then if you need to make predictions, you can use a normal distribution for that. There are many other distributions, not just the normal distribution. And we're going to learn about some in this course. Okay, we're going to learn about some specific ones, but not too many. But the idea is to make you aware that we can make predictions if we identify a pattern. Without a pattern, it's hard to make predictions and know what to expect. And the distributions, the ones that statisticians have developed, assist in that way. The normal distribution is a characteristic that you see with other symmetric distributions when you have a large data set that can exhibit it, like standardized scores on a test, like a LSAT or like the College Board tests, right? Thousands of people take those, and they will see that there's pretty much a pattern of normal distribution. Heights and weights in a population are normally distributed. And but as I explained, I think in the lecture, not all distributions are symmetric, and of course they're not the special case of a normal, right? And you do need to be aware of that. So that's why you have to make a graph. You have to do these checks, right? What's an example of, if you guys reviewed the videos, what's an example of a right skewed distribution? What variable would have a right skewed distribution? Give me some examples in the chat. Give me some different examples in the chat. What variable, what characteristic has a right? So that would be where most of the data is together, close together, but some extreme values here. Some high values, extreme high values. What variable? What would be an example?
I would say maybe like the median income or something.
Right. Income, right? So you often hear about the 99% of people are here and the 1% rich people are over here, right? So that's a perfect example of a right skewed distribution. So when you hear people report on income in the news or you read it in the magazine, they should, and they usually do, talk about the median income. They do not talk about the mean or average income. When they talk about average income, it might be in just one of the groups. So if you're talking about the lower, lower income people, they might talk about the average because they're all similar. They're not so right skewed in the lower income group. Or the middle income group, they're much less variation. But when you talk about all people in a society, there's usually some extremely rich people. What's an example of left skewed distribution? So you have most of the values, most of the observations have a high value, but just a few have a very low value of that characteristic or variable. What's an example?
The grades from school, something like
Yeah, you remember my example.
grades.
So yeah, so most kids will get there. So if you talk about grade school completed, so up to grade 12, most students will finish grade 9 or 10. You know, a bunch more will just graduate and earn grade 12, but very few will have 0 grade school and education. But it's possible that there are people who are mentally challenged and they can't go to school, or they're severely disabled, they don't go to school, so they're down here. Okay, so that's your tail. And so very few extreme values, but most people have achieved completed higher levels of school to grade 12. All right. If there's anyone who has trouble with my language and interpretation, please let me know. This video will go into YouTube, so you can use the translator and hopefully it translates me well and you can follow what I'm saying. But if you have any questions, you need to meet with me, you can ask those questions. Don't hesitate to let me know.
Professor,
Sorry, was my microphone off just now? I was talking.
Professor, I have a question.
Mhm.
So later we were talking about the observation minus the mean, right? And you told me that if we did the sum of them, it will give 0, right? But that would be if it was symmetric, right?
Should always be.
But if it gives me like a negative value, then it will be right scoot.
Nope. No, the issue is, let me go back here. Let's just do this quickly. I don't want you to get stuck. So if I did this quickly and I said, okay, 820 is the mean, and I subtracted each value by 820. So 2 minus 820, what do you get?
Negative 6.2.
Okay, 8 minus 820.
Negative
0.2. 10 minus 820.
1.80.
Yeah. And 16 minus 820.
7.80.
And 5 minus 820.
Negative 3.2.
And now add those together and you will get 0. If it's skewed or symmetric, you will get 0. It's just the nature of what the mean is. It will always give 0.
It's because I try to did do like an Excel of that, different type of values.
You
And
can
then like,
show me later what you did. It might be because of the rounding and the decimals. It could be just that.
okay, you're right.
Okay. But if you want, we can look at it together. You can send me, we can meet and talk about it. But it has to. It has to. It might just be a rounding error. But this will always be 0. Because it always be 0, that's why we square. The alternative is just to remove the negative. Like you could just drop the negative, but statistics developed by squaring. So instead they square 6.2 square.
It was, now I rounded them and it gave me 0.
Exactly. Yeah. It's always going to be the rounding thing. Got to be careful. I'm glad you're looking at that. You know, it's really important to me that you understand statistics is about averages and relative measures. That's what we do here. So don't lose that concept at the very beginning or you'll be lost towards the end. All right. So then what I'm going to do is sum these. So you can sum them in your calculator like I taught you in the data mode. Well, let me go back to the calculator for a moment. Let's put these in the calculator so I can finish with the calculator. Is there anything major anybody wants to talk about before we leave? Because I think, oh, somebody asked me to do the outlier calculation. We can look at that before we go. Okay, let me show you on the calculator. Let me know in the chat if you bought the calculator, or you got the calculator, so I'm not just wasting my time or wasting everybody's time showing. But I do prefer you to have the calculator. All right, so if I put this into data, oh, there's something already there. Okay, Elizabeth. I put something in there, so now I need to clear the calculator stat modes. The way I do that is I hit second, and what down here on the bottom left corner is clear work. Now it's clean. Okay, so I have to clean out the data in there. I'll do it again. Let me put the data in. Let's put the data in and then I'll do it again if you didn't follow. So 38.44, enter, down, and I skip Y, and then 0.04, enter, down, down. 3.24, enter, down, down. And 60.84, enter, down, down. And 10.24, enter, down, down. Okay. All right. Did you follow me? Should I wait? I'm faster at this because I've been doing this forever, but I'll slow down. I'm just using that for practice. If I add those, you could just add those in the calculator. There's so few values, you can just use the regular mode of the calculator and sum them. And what would you get? If I do second stat, I get, remember the linear estimates. So N was 5. This is the mean, 22.56 is the mean, but I don't want the mean. I want the sum. So I need to multiply by 5 to get the sum. I'll write it down here, what I did. I'm gonna write that. It was 22.56. You can't get the sum. If I keep going, let me see. So that's the mean, so that's again the standard deviation of the population. That's the standard deviation of the sample. I want the S, not the sigma. Sigma is the word. So, okay. There's no data. Yeah, it's not going to give me anything. Can't forget it. I was going to try and show you something. All right. So with that, that's the average, but it doesn't give me the sum. I have to multiply by 5 to get the sum back if I do it that way. But it's a way to use the calculator. So now I have the sum. So what I have is this. Now I have to divide by 4. When I divide by 4, I'm going to clear my pad here. So I'm going to take 112.8, not divide by 5, I divide by 4. This is called the variance. Okay, so here's a question for you. Here's a question for you. These are dollars, correct? That's the units that I use. These are dollars. These are all dollars. These are dollars too? Okay, everybody's okay? These are dollars. The deviation from the mean are dollars. And even though I just showed you this, please watch the video, okay? If you didn't see it, please watch it because I go much slower. I'm kind of rushing here. Just to practice proving the calculations work. Are these dollars? The deviation from the mean squared, is this dollars?
No.
How many people think these are dollars? Who told me no? Inaru? Who told me?
No, it wasn't me.
Oh, okay. Someone told me no. No, they're not dollars, right? Because if I square the value, I square the unit. So this is dollars squared. But nobody says that. It makes no sense what it is. We're not going to write it, but it's not dollars but it is dollars squared. It's not dollars. So when I write variance, I cannot put any units. Okay, it's just 28.2. The last step will bring back my dollars, and that's why we have to do it. We have to return our value to the units of the problem. So 28.2 square root is now dollars. All right. We just use the squaring to eliminate the sign to preserve the distance to capture the variation from the mean. How far off are the values from the expected value? That's what we figured out. All right, so that's that. So you're going to practice all of that. Let's talk about the outlier calculation someone asked me about, and that's going to be found. Well, I'm going to pick up my other set of notes. The annotated notes, which you shouldn't look at until you read the notes, but I want you to try and solve the exercises that I present to you, solve the problems before you look at the annotated notes. But I like my drawings on here. They help me with my description. Okay, so which one would you like to look at? There's a 5-number summary presented as a box plot. So this is a new graph, box plot. Is this a good one? Whoever asked me for this. Oh, let me see who asked me.
Mi pregunta es más bien porque no sé cuál de las dos fórmulas utilizar en la regla de decisión.
¿Cuál página?
En la página 17, tal vez la 18 en la de inglés.
Ok. Aquí.
No.
¿En dónde? I think. Do I have different pages?
Creo que en la página más arriba. Esa parte.
Okay.
La decision rule.
Ah, the decision rule. Okay. All right. If this bothers you, this looks very confusing, always just go with the drawing, okay? So the idea is on this side is the tail. So this is the 5-number summary if people didn't arrive here. The 5-number summary presented for the spending data is here. So this, remember, $2.32. And remember, Aritza already mentioned to us that we have to have the original values. Even though we use the stem and leaf plot for the 5-number summary, for the 5 features, we return in our calculations to the data, or we're going to have different answers. You want my answers, so you need to use the original data. So here's $2.32 minimum. $69.49 maximum. And then we have the median for the 5-number summary and the 2 quartiles. What is a quartile? A quartile means that in this below here is 25% of the data. This quartile or the median, also known as the 50th percentile, you have 25% of the observations here and 25% of the observation here for 50% below. So that's why it's called the 50th percentile. And then this quartile has 75% of the observations below. So this is 25, this is 25 and 25. They're different shapes. There are different lengths because the data is more spread out in here. The data is less spread out here. Now here's a long spread of data. We want to find out if the data over here, remember the 4 shoppers spent a lot more money than the rest of them. So what we do is we take, so from data set to data set, from different contexts, from different narratives, we have different ideas of what is big and what is small. In terms of this data set, we're going to call this the regular range or the interquartile range. Okay, so this is our measure of normal, like regular, a regular pattern, nothing extreme. And we're going to use it and extend it here and then 1/2 of it. Here, well, I guess I go further. Up to here is 1/2. Let me do it again. Make it work. It'll work if I do that. Well, anyways, it's supposed to work. I think I didn't make that long enough. All right, so what I'm doing is taking this distance and treating it as 1.5, and I mathematically hit here. So 1.5 of this range is 19.45. So this is the picture, this is the number, 19.45 times 1.5 takes me up to here. Any values beyond here are outliers. That is how it works. And you only check, verifica solamente al lado with the tail, no en ambos lados. No tiene que verificar en ambos lados. Except if you have tails on both sides, okay? If you have tails on both sides. Now, can you have tails on both sides? Yes, you can have a very flat distribution and you can check on both sides. But usually you're checking one side when there's skew. That's what we do on one side. Did I answer your question?
Sí, ahora sí, gracias.
So then you go here, 62.975, and you have to regresar a los datos al inicio or at the start. So you look for this number. Let me copy this number. All right, here. All right, so this number, after this number, you have outliers. 61.57, let me make this bigger. So the outliers include those 3. This one, no, because it is not beyond 62. Okay. All right, it's almost 11:30. Any more questions from you to me? Any more questions? Anything you want me to?
Yes, Professor. Could you include in the class webpage? I know that we are near to finish the class, but I saw a quiz, the quiz number 3. We have the determination of IQR. I think that was second quarter. I don't remember, but we include variables. And I want to know.
Let me open it. Let me open it. I'll open the page.
Yes, if the quiz number 3, I think that was the question 1.
So is this working in general for everybody? I'm not wasting your time. I don't want to waste your time. I'm trying to help you. I don't want to create more examples. You have enough to watch. So let's make the best of this time. Next week, you should be finished the material and I can start giving you extra problems we can study together, right? We can start studying. Every time we work together, we're preparing for the exam. All right, number 3.
Yes, a quiz number 3. Yes. The question 1.
Aha.
Yes.
So first step. What's the first step?
Organize the values in order.
In order. Perfect.
Yes. And then let me check my.
Okay, let's just do it together. I get it.
Okay.
Okay, I'll have to write it out on my page. Okay, so we're putting the numbers in order. 15. Next, 20. 23. 30. 35. 50. 56. Did I miss any? 1, 2, 3, 4, 5, 6, 7.
70.
70, okay.
Mhm.
And then we have 2 low values. I'm going to put them here. Now, this is making my point about if you were to calculate the median, it doesn't matter. You don't have the value, right? Because the median is away from the extremes values. So, okay, what is the value of the first quartile of these data? Okay, so we have how many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. So the median is found at the n plus 1 divided by 2 observation. So that is 5.5. So it's an even number. When I add 1, it becomes it's an even number. That means there's 2 values in the center, right? So you count 1, 2, 3, 4, 5, 6. So between here and here is the median. So I'm just going to go like this. I don't need the exact number. The median is in here. Now I've divided the data in 2. And I have to get the new center. Actually, this one's not hard, right? So I have to get the new center. So what's the center of the first half?
15.
Yeah. And what's the center of the second half?
50.
So we can see it. It's easy. When you have a lot more numbers, you have to use the rule again, the same rule, n plus 1 over 2, but your n changes 1, 2, 3, 4, 5. Your n changes to 5 because it's half of 10. There's 5 values in each half. So it's at the 5 plus 1 over 2, which is the third observation. It's not observation. All right, so I didn't have to do that. I didn't have to do all this writing because it's clear to me. So that's it. That's how I get the answer. But Carla, you were thrown off by the 15 plus L.
Yes, I think that I was confused because the variables, but
Oh, I see why they did that because because if you didn't rank them, so if you just copied them, so they're tricking people, who didn't do it right. So what they did was they went, okay, 30 L 20 56 35 L 15. So if you didn't put them in order, you would get the wrong answer because you would say that the median is 1 2 3 4 5 in between here and here. You see, that's what they're getting at. And they're averaging these. And then here, the first quartile would be 20. Anyway, you have to be really not understanding to pick the wrong ones there, if anyone did it. But yeah, so no, you were just getting thrown off. So once you put them in order, it's clear what the answer is. So if because that would have been just here and here. If you were to get the median, if somebody asked you with this data to get the median, still this is wrong because they're not in order. But if from this list you had to operate, you would average those two. That's what it was doing. It was getting at. But I didn't even get the median here. What would be the median in this problem? 23 plus 30 divided by 2. You see, that's where the idea of dividing by 2 comes from.
26.5.
Thank you. 26.5. We didn't have to do it. Okay, good. Thank you for the question. Anything else? You guys can let me know if this is working for you. You can let me know if it's not working for you. Let me know if you're having trouble keeping up. If you want me to go back, if you want to meet with me, we can meet by Zoom. If you want some direction of focus, let me know. But in general, let me review the website. So what you're going to do for the rest of the week, you're going to continue, or if you haven't started yet, you're starting today. And you're going to print the 2 sets of notes. Don't look at the answers until later. You're going to watch these videos, and these are the backup videos. If you miss something in here, you didn't understand it well, you can watch the backup videos. You don't have to watch all of these. But like there's 5 hours here. It's mostly, it's 4 hours. Yeah, 4 hours in here. So anything that's missed, you're going to capture it in here. This is old. If you want to see some old videos, if you feel still you don't understand, see it a different way. These are the exercises you're going to complete. And next week, if you've done all of this and you come prepared, we will not have to review more. Maybe I'll answer a few questions and I can begin showing you, like I did last class, the old exam questions, some other old exam questions we can practice together. Okay. And maybe I'll do an introduction. I already did a little brief introduction into the normal distribution. We can talk a little bit about the normal distribution, which is the next module. All right.
Professor, regarding the Connect, I saw that we have a bunch of assignment, but they have other dates. We must perform or complete these assignments,
No,
or
just
we
wait
wait.
until I
Okay.
post them. Yeah. The problem was that those are from the past and I didn't put those up there. It was the McGraw-Hill representative put them there. She just renewed them, and anyway, ignore them until they're ready. When they're ready, I will email you, okay? You'll get a notice when everything's ready for you.
Okay, thank you.
Thank you for asking. ¿Estamos? All right, I hope it's helpful. Let me know and keep in touch. Nos vemos la semana que viene.
Gracias, buenas tardes.
Gracias,
Gracias,
buen fin de
bye, buen día.
semana.
Buenas tardes.